Hello YouTube, and welcome to this quick video about a script I made. I made a video already, but I realized after watching it that I forgot quite a few things. The point of this video is that I made a script that will take an image of an SD card, figure out what the second partition, well, the largest partition on it, figure out how much space is actually used in that partition, and then shrink it to that plus 50 megabytes. And then shrinking the image file down to that size so that you can have a small image file for use in backups or distribution, for example. So yeah, and in the last video I made, I actually forgot to show you what it took up afterwards. So in this video, I'm just going to go through the script like I did in the last one, and yeah, I think that's going to be what I'm going to do. But I'm also going to show you the size benefits. So first of all, my script is called resize image. I've entered. This is right. Okay, so this is SSH to my laptop because the script has to run. It has to be used on Linux, basically. There are a few requirements. You do need. Let's see. You do need. Here, let's open the script up here. So you do need to have resize to FS installed, and you do need to have dump E to FS installed. I would also recommend installing DCFLDD. It is basically a bit better version of DD that has a progress indicator as well. But as you can see in my script, it can use DD as well. So basically what the script does, and let me show you how to call it, you go sudo, you have to run it as a super user, and then resize image, then let's just figure out, I'll just go over and I'll replug my SD card from a Raspberry Pi that I have in it. Right, so now I have plugged in my SD card, so I'll run df-h. That'll show me where all of the things are mounted to. And as you can see, my SD card down here, MMC BLK0, has been mounted to this random folder and this random folder. Well, boot. We don't want that, but that is why the first part of my script unmounts everything. So let's start the script. I have changed something about the script and haven't checked it, so let's see if this works. But anyways, we want to resize an image of, well, we want to take an image of and resize it of MMC BLK0. Don't add any partitions because it's the entire card we want. So just this. And then we want to output that to home/miggle/test.image. Yes, okay. You must be root user. I actually forgot this again. But yeah, that's one of the things I added without testing. It actually checks now. So sudo do what I just told you to. There we go. So something I did to it has messed it up. What did I enter? Yeah, I know what I did wrong. Okay, so you see I entered MMC BLK0. I have to give it the full path. dev/MMC BLK0. There we go. So now it'll use DCFLDD if it's available. If not, it'll just use DD. But you can immediately see the advantage of using DDF's the long name. It shows you how many megabytes it's read and written to the local image file. So it gives you a progress bar. So while it does that, let's go through the code. I have a huge blurb here that I just took from MIT license stuff. It's because in case you fuck up stuff, I don't want to be responsible. And I want it to be absolutely clear that I'm not responsible. So that's what this scary big all cap stuff is. Check that the required arguments have been passed. So this is one of the things I've added. You do need to pass it both arguments. So if you don't, it'll tell you the usage. And exit with an error code. And this is the you must be root. I found that from Nixcraft, I believe. And then it unmounts all of the partitions. So in our case, it'll unmount partition 1 and 2. I can't scroll because it's constantly updating down here. But yeah. So yeah. The next thing it'll do is check if you have DCFLDD installed, and it'll if it does that, it'll take an image of the SD card with that. Otherwise, it'll use DD, and it'll sync afterwards just to make sure all caches have been cleared through. And then it'll change the ownership of the image just created, because this script is running as root. And for getting the username of who's using sudo, I use who mom likes, which is basically who am I, but there's a who am I in one word, but that's not quite as foolproof as who am I, and this is just another way of writing it according to the man page. It accepts both. This gives us a bit more than the username, though. It also gives us a lot of other stuff. So I just use awk to grab the first part, and then I use the same username for the group as well. So I changed the ownership of the file to the group and user that ran the script, basically. And I have to use this because it is actually technically root running the script, but it is another user running sudo and then running the script, and that is what who mom likes gets, or who am I gets. So that's why I'm doing that. So the next thing we do, yeah, and by the way, $2 in this instance is the second argument to the script, which is the image file. So the next thing we do is we find the, oh, right, it's very important that I mention this. I forgot. This is entirely based on this thing I found after about 1 minute of Googling on how to take an image of a Raspberry Pi and make it small so that it's easy to transfer or store or whatever. I mean, there's no reason to take a full SD card image. Imagine if you had a 32 gigabyte SD card in your Raspberry Pi. Every single DD image of that would be 32 gigabytes. So this will actually make it about as big as what you've used on the SD card. This is based on this great guide from oakley.com, and just basically scriptified. And instead of using gparted, which I think is a bit overkill, the guide is telling you to install gparted. I am just using what gparted is actually using, which is resize2fs directly. Right, so that's out of the way. That is where I got all of this from. Well, that's where I started, and then I scriptified it and got some help from an ISE and on Google. So this next part here is we have to find the start block of the second partition of the image, and this is rather specific for Raspberry Pis. I mean, this does not find the second block. This finds the largest block, to be fair, of any drive. So if that fits your use case, hey, you can use it there too. But this is pretty much for Raspberry Pi images. So what it does is it goes in this awk I got some help with. Well, that's putting it lightly. I asked for help on IRC, and a very friendly guy gave me this, and it works great. From what I can understand, what it does is it goes in. This command is basically fdisk list all partitions of the image, and only show me the sectors column and the start column. And sectors is basically how you can in awk you can see that the one that has the most sectors is the largest partition, and then start column as well, because we want the start block for that partition. Then in awk you basically look for sectors and then some wildcard start, and then when you find that, you set F1 and go to the next one. So as long as we found that, I think that's what it means. And $1, where's $1? Oh yeah, that's column 1. Plus 0 is greater than sectors. So I guess this is the part that compares which that finds the largest partition basically, and it saves Then it saves sectors into $1 so that if it didn't find it this time, it loops over so every time it finds a sector that is bigger than the previous, it saves the start block for that. And then when it ends, it pretty much just spits out the start block, and I save that in start value. Oh, this is the first time I actually understand this. Huh. Okay, cool. So the next thing we do is we connect the image to our loopback device. First, we just clear it to make sure that there's nothing attached to the loopback device. And then we attach the image at the start of the second partition to the loopback device. So now we can use this as if it was a normal hard disk with only that one partition though. So the next thing we do, and this part I had to come up with myself, because at this point I was no longer where I was early. It was later in the day, and I decided I wanted to learn org. So what this does is you go into dump EFS. The purpose of this is to find out what the minimal size you can possibly use. Well, the minimal size you can resize it to is. So what it does is it goes in, it finds the block count. So how many blocks is it total on that partition? How many free blocks are there? And what is the block size? And then it goes in, it says how many blocks are the total minus how many are free. And then it times that with the block size, so we get how much space have we used, and then we divide it by 1024 twice, so we have it in megabytes. That's going to give us a comma number, so we don't want that. But we add 50 megabytes just to give us a bit of air to breathe, and then we cast it to an int, basically, which rounds down. So in worst case, it'll round down to, so we only added 49 megabytes, but that's okay. This is just a bit of air, just a bit of buffer space we're adding. So that'll give us that, and then we add an M to the end. Basically because now we have a text string that's the new size in megabytes. And we use that down here in resize to fs, partition, loopback device, new size, and then if this just does it and there's no error code. Wait. Yeah, okay, this works. Yeah, so if it does it and there's no error code, it'll just echo nothing. And yeah, cool. Wait, okay, I'm not quite happy with this. I thought that when it does something successful, it should echo 0. So basically, no, okay. Well, it works, so what am I to judge? If it fails, it's going to give you this message that you got over here, and it is going to give you that message because either it'll run into a bug where it can't accurately evaluate the minimal size you can set the partition to. It's a known bug, that, or it's, in this case, saying that please run E2 file system check, I guess that is, first. I don't want to do that. Hasn't been a problem when I'm not doing it. So, hey, who cares? So the next thing it does is, if it fails, resize to file system failed. If it's complaining, you can try and force it. Want to force resize the copy. Your SD is never written to during this script. It's never intended to be written to, at least. I can't guarantee that something won't go wrong. And let's just say yes to that. And it'll start doing that. And it basically just runs it with the force flag as well. If you say no, it'll exit with an error code, basically. So the next thing we do is we go down here, we remove the image from the loopback device again, and then we attach the entire image, not just the second partition. And then the guy calls for using fdisk, and I didn't want to have to redo all my homework again and using sfdisk, which is script fdisk. And I found on Google that you can pass text directly into standard in from bash script in this manner. And this is just a bit prettier manner, in my opinion, where you have this set regex to strip off all of the comments so that you only get this D, enter, 2, enter, N, enter, P, enter, 2, enter, and not all the comments as well. And that just allows you to actually comment all the way down so people can see what you're doing. And what this basically means is pipe whatever is coming from now on directly into standard input until you read end of file, and we pipe whatever that is into fdisk/dev/loop0. So fdisk is basically seeing someone pushing D to N, P to the start block, the new size of the partition, write these changes to disk, quit, and then it finds end of file, and now we're back to a script. And what this does is that we have resized the partition now, but in the file system, the partition is still listed as being the original size. So what we do here is we just go in and change the partition table to say to reflect the changes we've made and say it's now a much smaller partition. And that's necessary for it to be readable at all. So yeah, that's what we're doing. But we still have just the image files is still just two partitions, a small one of 60 megabytes and a now smaller partition, and then a whole lot of unused space now. So the file is still the same size. So the next thing we have to do is figure out where does the second partition end, and we do that with a similar command to the finding the start up there. And then when we find that, we go in, we deattach it again, or whatever that's called, and then we truncate the file down to this, well, to the ending block +1 times 512 bytes, I believe. And when we don't do that, we basically have a much decreased size file. So yeah, then the next thing we do, getting extra marks, is basically just those extra 50 megabytes that we put in. There's no need for those to be actual data. So we just go in, we set it up again as a hard disk with only the second partition connected to the loopback device. We make a directory in mount image root. We mount the loopback device to image root, and then we use dd. I didn't feel like using the if statement again down here because this is very quick. To just throw a bunch of zeros into the text file, into a text file in the smaller partition 2 with those 50 megabytes. So we just throw zeros in, then we delete the file again because we don't want a file to be there with all of those bytes actually associated to it. So we delete it so that space is free again, but now we know that it's zeros. And that's important because when we then unmount the SD card again and then remove the folder we used for mounting it, and then disconnect the loopback device, when we do that, basically that unused space will be 0. So if you compress it, it'll be very efficient to compress. Instead of having a lot of random data there, you can basically just say, oh, there's 50 megabytes of zeros, so 50 million times 0, and that's much shorter to write than 50 million different pieces of data. And then we're done. And that's it. So this is an 8 gigabyte SD card. So normally, if you were just making this image, it would be 8 gigabytes. So let's see ls-l home migl goddammit grep, and I called it test.image, I think. There we go. So this is now this many bytes. So let's just take that and can I just do this? Divided by 1024 divided by 1024. That should give it in megabytes. That is now 1.611 gigabytes instead of the 8 gigabytes. And this is with a full streaming platform installed, by the way. That's what this image is of. So yeah, this is that's running Raspbian Jessie and a UV4L video MJPEG streamer. Instead of 8 gigabytes, we now have 1.6 gigabytes. That is a great improvement, if you ask me. And then let's try and zip it, actually, to be fun, to just have some fun. zip/home/magle/test.image. Oh, I can't remember I think it's you have the zip file here, and then you take the file you want to add. home/magle/test.image. No. Oh. I need an L there. Wait, what? That's embarrassing. I forgot the zip command. Let's just find the zip command then, I guess. Yeah, image name.zip, image name. Zip home slash magle slash. Actually, let's just put it here. Zip file.zip and then home slash magle. Oh, I had a random semicolon in it. Okay. Slash test.image. There we go. I don't know how long this will actually take. Usually there's a progress bar, but I guess there's no progress bar with SSH. Here, let's open another let's open up another terminal. I'll just bring that up here instead of adding it. Let's see if we have ls resize image. I don't know what suffix called is, but I guess that's a temporary file. What is top doing? Zip is using 100% CPU. Ah, I guess it's working hard. CD resize image ls l. Right. Okay. How much is that in megabytes? Echo this divided by 1024. Okay, it's getting there. Oh, there we go. Deflated 63%. Cool. It is, that means it's compressed down to 63% of the original size. ls-l. Yeah, okay, that's pretty good. Echo this divided by 1024, 1024. 529 megabytes versus 1.6 gigabytes. Damn. Okay, that's pretty efficient. Well, that's my script. Thank you for watching. Bye.